Hello class, one of the things I want you to be able to do today is to be able to tell me how we're going to solve drawing, how use a scale drawing to solve real world problems. So have you ever seen a floor plan of a room or house? Maybe like when a parent was looking at apartments, or maybe you were thinking of doing some changes around your own home. Well, I want you to take 5 minutes and I want you to try to draw a floor plan of our classroom. I drew a rectangle. Our class is kind of a rectangle. And the door is up in the corner. And see, I made a little mark for the door right here. But what would your drawing look like? And then maybe where would the board go? And where would the teacher desks go? Decide if you want to put shelves in your drawing and student desks. Just where is everything at? I want you to turn and show your picture to your neighbor and see if they look similar. So, what would help our drawings be more accurate? What kind of information would be helpful to know? Would it be helpful if I told you the paper has to face this way for a drawing? Would that help everybody's look a little bit more the same? Okay. What if I told you that you could only take up 8 lines? So if the top of it was here, 1, 2, 3, 4, 5, 6, 7, 8, and the bottom of the room was here. If you couldn't take up the whole page and it just had to go here, do you think that some of our drawings might look a little bit more similar? Okay, so if you can only take up 8 lines, how far up would the teacher's desk be? Everyone look at the teacher's desk real quick. And is it about halfway up the class? Would knowing that, being able to count that, would that help you space your drawing? What else would help you? Okay, actual measurements, good. Well, but there's a problem, like you can't make a drawing the size of our classroom. That's not going to work. Could we like agree to a certain like comparison for every, I don't know, foot you used one line? Do you think that would help everybody's, if I did give you measurements? If we agree on a ratio, maybe a comparison. Okay, well, here is a drawing, and in your journal I want you to fill out this table. So in the blueprint, if it's only going to take up 4 inches, that 4 inches is going to be an agreed upon ratio that means 3 feet. So if that's true, I want you to try to fill in the rest of this table. All right, let's see how we got. Did you get something like this? So on the part of the table where it says that his blueprint, the side of his blueprint is 16 inches, that's here. What is the actual length of the wall there? Right, 12 feet. if the back wall is 33 feet long, back here, if this back wall is really 33 feet, it's not going to be 33 inches in the drawing. What would be the length of the drawing? Our table doesn't go that far. How could we find that out? Okay, if we skip count, is that going to take us all the way? I think we could go from here to here and times it by 11. Good. Here to here and times that by 11. It would be like the 11th box down maybe. So that would be 44 inches. And how do you know your answer to 2 is reasonable? I want you to think about that and share with your neighbor. Did anybody say we came up with proportions? Good. All right, so we have some notes I want us to look at together today. We're going to use what we know of similar figures, and we're going to look at scale drawings and come up with the size of real objects. So the first thing that we have to do is set up a proportion. And to do that, we need to include units. It's going to help us line our stuff up. So, for example, you can see over here on the left that 1 centimeter is 10 feet, right here. So, we want to look at setting that up. So they take it and look at it here. All right. Let's look at this right here. The plan of a terrace is shown at the right. Anybody know what a terrace is? Because sometimes the words they use are pretty confusing. A terrace is like a porch, a front porch or a back porch. So the scale, that's an important word, is 2 inches to 6 feet. So we're going to set up our primary ratio. That's what it's going to be, primary ratio. Write that down. Our primary ratio is our scale. So we have 2 inches represents 6 feet. If that's true, what is the size on our terrace? Now we have a length and a width here, so that means we're going to have to do this twice. Let's pick a side first. Let's do this side, 5 inches. So if I'm setting up this proportion and I want my labels to match, is 5 inches going to go on the top or the bottom? Right, it's going to go on the top. So here's my unknown value. Now to solve for that, I'm going to cross multiply. 6 times 5 is 30, and 2 times my unknown is 2x. So 2 times something gives me 30. My opposite operation there is division. So x is going to be 15. 15 what? 15 feet. So the length of my drawing is 15 feet. That's going to be the real porch. Obviously, the real porch is not 5 inches long. That's crazy. So the other side of it is 2 inches. So let's look at solving that one. We go back to our primary ratio. 2 inches represents 6 feet. Now in my picture is 2 inches long. Oh, but I can see right here our missing piece. Sometimes we don't have to cross multiply. We can look for a side-to-side relationship. This right here is equal. So if 2 equals 2, then 6 equals 6. 6 what? Obviously not 6 inches, because that's a tiny porch. 6 feet. Good. So this one is going to equal 15 feet, and this one's going to equal 6 feet. Now, if I wanted to know the area of that rectangle, I know that's not the topic we're on, but could I find the area of that porch, of that terrace? How do I find the area of a rectangle? Length times width. So I could actually find area of that rectangle either in the drawing or the actual rectangle, the actual terrace. Good. All right, let's look at the next one. The floor plan of a ballroom is shown as right. The scale, important, is 3 centimeters, represents 4 meters. That's our primary ratio. So I'm going to write that off to the side. That is 3 centimeters and 4 meters. 3 centimeters represents 4 meters. So if I set up a proportion, I'm going to make sure that my measurements are going to line up. All right, so this rectangle over here, what is the length and width of the ballroom? So let's start with this side here, 12 centimeters. So when I look at my ratio, is 12 centimeters going to go on the top or the bottom? The top. Good. So this is what's missing. So before I cross multiply, divide, do we see any side-to-side comparisons? I'm going to say, write that down, side to side. Okay, I can tell right now that my side-to-side comparison is times 4. So down here, I can do times 4. So what is 4 times 4? Right, that's going to be 16 meters. And that's my length. So my length is going to be 16 meters long. My other side is 9 centimeters. So I'm going to come back to my primary ratio. 3 centimeters represents 4 meters. And if I set that up in a proportion, I got to keep those labels, centimeters and meters. So we're converting 9 centimeters. 9 centimeters. So this is my unknown. Before we cross multiply and divide, let's look to see if we have any side-to-side relationships here. Can 3 go into 9 easily? So we're going to times that by 3. We do the same thing down here. Times that by 3. So 4 times 3 is 12. X equals 12, which is going to be 12 meters. So the width of this rectangle is 12 meters. This is the floor plan of a ballroom. That's a dancing place. Ballrooms are where people dance. Now, again, I could find the area of this rectangle or the ballroom if I wanted to, now that I know their real measurements. The real measurements of this one is 16 meters, and this one is 12 meters. All right, this one, number 3, does not have a picture. So we have to either draw it or think about that. A garage floor measures 150 feet by 120 feet. So this started off at 150 feet and 120 feet. The scale drawing, scale, has a scale of 1 unit, ... 15 feet. So that's our primary ratio. 1 unit represents 15 feet. So what are the dimensions of the drawing? All right, so we're looking for some smaller numbers here because we want the drawing. So if the real garage is 150 feet long, let's look at this. So we have units and feet. So 150 feet. Do we see any side-to-side comparisons? Well, I can see this is times 10. So here I'm going to go times 10 and get 10 units. 10 units for that drawing. So 150 feet is 10 units. I'm going to go back to my primary ratio. 1 unit is 15 feet. So that I'm looking for units and feet. And now we have 120 units, or 120 feet. Okay, so now I'm going to look for my side to side. Oh, there's no side to side there, so I can't do that. So I'm going to have to go back to this and solve for x on this one because there was no side to side. That's okay. So this is 120 times 1 and 15 times x. So 15x equals 120. So this is our one-step equation. I'm going to divide that by 15, and we get 8. X equals 8. 8 what? Well, we're looking for units. So let's add that to our blanks here. We're looking at this. This is going to be 10 units. All right. Lastly, scale drawing. And anytime we see that word scale drawing, that is an automatic clue. Make a note to yourself. Anytime you see the word scale drawings, that should tell you you're going to make a proportion. Because it's not always going to be just scale drawings. So it uses the scale of 4 centimeters represents 9 feet. There's our primary ratio. So I'm going to write that down. 4 centimeters represents 9 feet. So my comparison has to go through the same thing, centimeters and feet. All right, what are we looking for? The length of the billboard in the drawing is 11 centimeters. So over here in my ratio, I'm going to put 11 centimeters down, and here's my unknown. All right, first thing I'm going to do, look for that side-to-side relationship. There is not one, so we can't do that. So instead, we have to cross multiply. Look at those great cross products. So we have 4 times something is going to have the same value as 9 times 11. So 4x equals 99. Divide by 4. Divide by 4. And x equals... That does not go in there a neat amount of times. So we're going to need to do some long division. And when I do long division, I like to use graph paper. Okay, so let me switch back to my pen. Four goes into 99. 4 goes into 9 2 times, and we have 8, and we subtract to get 1. Bring down our 9. 4 goes into 19 4 times, and we get 16, and subtract and get 3. We're going to need to add a 0. Bring that down. 4 goes into 30 7 times. 7 times 4 is 28. Subtract that and get 2. Need another 0. Making it rain zeros. 4 goes into 20 5 times. That's a 20. Subtract and get 0. Graph paper really helps your long division stay straight. So 24.75. So when I go back to my solution, the final answer is 24.75. But 24.75 what? Well, my missing measurement is in feet. All right, so we have some practice problems that you can work on. Be sure to use your measurements, and when you finish, we're going to turn this paper in at the end of class.